This is page number 15. First question. In which case a vertical gas tube waste heat boiler preferred to its horizontal counterpart? The answer is it is preferred when it is a prime necessity to save floor space. Next question. A vertical gas tube waste heat boiler with a shell diameter of 2.5 meter is rarely found. What is case of such limitation? This is due to limitations inherent in transportation and drum attachments. Next question. What are water tube boilers most frequently used for waste heat recovery? Answer. They can work successfully at higher pressure. Next. Since water is circulated in the tube side which can be readily cleaned, water tube waste heat boilers are not too susceptible to damage from poor feed water quality. Third one, better capacity to withstand the shock due to fluctuation of gas temperature. Fourth one, the furnace wall can be adequately cooled by applying water wall tubes. This imparts a long life to the refractory land waste heat boiler interior wall. Fifth one, the slagging and erosion problems can be minimized by varying the tube size and spacing. Dust particles may be required, lends itself to a more economic arrangement. Next question. What are the primary consideration in designing a waste water tube WHB? Answer. The design considerations should primarily focus on two major problems. These are problems due to sticky dust particles and problems due to heavy dust loading. The cooling and subsequent elimination of sticky particles is necessary before their entry into the convection shaft to the waste heat boiler. Otherwise, they will deposit on the external surface of water tubes and impair the heat transfer characteristics. Hot gases heavily laden with dust particles may entail erosion problems for tubes as well as reduced heat transfer due to surface deposition of dust particles on water tubes. Question. What are the reasons that led to the application of bent tube boilers for waste heat recovery? Answer. These boilers can tolerate heavy dust loadings. The vertical tubes collect less dust. Greater flexibility in tube size, spacing and arrangement. Tube damage problem is minimized by more positive circulation. Allow pendant superheater installation. Less space is required for the tube removal. What is chief advantages of positive circulation of waste heat boiler? The unit is more compact and light as extremely small diameter tubes 30 to 40 are used, which can be arranged without regard to natural circulation requirements. This is the advantage of positive circulation waste heat boiler. Name a positive circulation waste heat boiler. Positive circulation law mount waste heat boiler. What are the application waste heat boilers? Answer. A waste heat boiler finds its application in 1. Steel mills, and the second is cement kilns, and the third one is ore roaster, fourth one is lead and zinc smelters, fifth one is paper making. So first one, steel mills waste heat boiler applications. Use steel mill use all types of small boilers: horizontal vertical gas tube waste heat boiler, horizontal straight tube boiler waste heat boiler, bent water tube type boilers. Waste heat boilers are fitted to open hearth, forge and continuous heating furnace, coke, even blast furnace gases being heavily dust laden need special handling in the burner. Cement kilns need a waste heat boiler that must be specially designed to handle extremely dust laden gas. Hopper are provided under the boiler and economizer to remove the dust continuously. As much as 20 to 40 tons of cement dust is recovered per day from single kiln. 2 drum and 3 drum waste heat boiler particularly used. These are fitted with economizer, superheaters and soot blowers. Ore roaster. A typical waste heat boiler for recovering waste heat from Ore roaster is a three-drum, low-head boiler fitted with hoppers under the sections of gas path to collect gas-borne ore particles as they settle when the gases make low-velocity turns around the baffles. Load and zinc smelters. These need a waste boiler capable of handling a gas whose temperature is high as 1450 to 1480 Kelvin degree Kelvin and which is laden with solids in a semi-molten or sticky form. Usually, a vertical waste heat boiler, water tube waste heat boiler is used, which must cool the gas down to 1000 to 1030 degree Kelvin in the radiant chamber to condensate out the metal, zinc, and Pb vapor from the hot gas before its entry to the superheater and convection shaft. Paper making uses waste heat boiler to generate process steam by burning the waste liquor, recover the salt cake, eliminate steam pollution. The waste liquor is dehydrated to produce char, which is burnt in a large heap in a reducing atmosphere in the recovery furnace. The furnace temperature is as high as 1500 degree to 1530 degree Kelvin. Gas velocities are kept low to avoid fouling of the heat absorbing surfaces which comprise water wall tubes laid on the refractory lined boiler furnace. The flue gas after passing through the economizer go through the evaporator to concentrate the black liquid. Next question. How are marine boilers classified? Answers: sectional header boiler, drum type boiler, positive circulation boiler, thermonuclear steam generator. Suction header boiler is either horizontal straight tube or sectional express type. Drum type is these are burnt tube boiler having double furnace or simple furnace. Then positive circulation boiler, then thermonuclear steam generator. Then next question. How are marine boilers typified? Answer: depending upon the specific usage of steam they produce, the marine boilers are divided into main boilers used for ship propulsion, auxiliary boilers used for running the auxiliary system aboard the ship. What are these auxiliary systems? Answers: turbo generators for electrical power generation, and water distillation, fuel oil heating, space heating, cooking, boiler feed water turbines. What are the factors used to be must be considered in designing a marine boilers? Answer: the boiler must be compact in size and minimum in weight. Maximum operating efficiency to be impaired by ensuring proper combustion and its control, efficiency, heat recover, adequate insulation, higher operating steam pressure and temperature. Third one is special design features must be affected to outweigh the effect of the ship's rolling, pitching, and the vibration of the steam generation. Eliminate gas leakage in the fire room. Minimize heat loss to the fire room. And fourth one is operation reliability is to be attained by correct designing and construction of boiler, proper installation of boiler unit, superheater and auxiliaries. Simplicity in design and operations, and complete accessibility to boiler internals for inspection, cleaning, and repairing must be ensured to minimum outage time. Flexibility enough to maintain constant steam temperature and pressure over wide range of steam loads. This necessitates large steam drum, large ratio of generating to concentrated water volume, and eighth one is fuel and its efficient utilization. Pulverized coal is seldom used because of space limitations. Almost all ocean liners use oil-fired boilers as oil burns more cleanly than coal. Oil leaves no ash. Oil needs 55% of the storage capacity needed for coal. Oil burning devices require less space. Remaining questions we will see the next video. Thank you.